Panel 2 has agreed to mandate arc fault circuit interrupter, or AFCI protection, for all 15 and 20 ampere circuits in a panel board when it is replaced in an existing home. However, it has not yet approved this requirement for new homes. The vote in the panel was indecisive, with abstentions and a lack of a 2/3 majority. It is currently unclear whether the proposed arc fault circuit interrupter protection requirements will be included in the code. In 2008, arc fault circuit interrupter protection required the use of combination-type devices, which can detect series faults. Parallel faults must exceed 75 amps for current arc fault circuit interrupter breakers to open the circuit. Therefore, focusing on each of these points provides a clear understanding of arc fault circuit interrupter protection requirements, voting status, current code status, upcoming changes, and parallel fault detection thresholds. Arc fault circuit interrupter protection is a crucial safety measure designed to protect homes from electrical fires caused by arc faults. Arc faults occur when electricity strays from its intended path, creating a dangerous electrical discharge that can ignite nearby flammable materials. There are two main types of arc faults: series arc faults and parallel arc faults. A series arc fault occurs when a wire is broken or partially severed, interrupting the flow of electricity and creating a small arc. A parallel arc fault occurs when electricity jumps between two conductors, such as damaged insulation or loose connections. Both types of arc faults can generate intense heat and sparks, posing a significant fire hazard. Arc fault circuit interrupters are designed to detect these dangerous arc faults and quickly shut off the power to the affected circuit, preventing a fire from starting. The National Electrical Code, or NEC, plays a vital role in establishing safety standards for electrical installations. The NEC is a set of guidelines and regulations developed by the National Fire Protection Association, or NFPA, to ensure the safe installation and use of electrical systems. It is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. The NEC is widely adopted by states and local jurisdictions across the country, and compliance with its requirements is essential for ensuring electrical safety. Panel 2 is one of the code-making panels responsible for developing and updating specific sections of the NEC. The code-making panels are composed of experts in various fields, including electrical engineers, contractors, inspectors, and manufacturers. They review proposals for changes to the NEC, conduct research, and develop recommendations for revisions to the code. Panel 2 is specifically responsible for Article 210, branch circuits, Article 215, feeders, and Article 230, services, of the NEC. The panel's decisions have a significant impact on the electrical industry, influencing the design, installation, and inspection of electrical systems. The proposed arc fault circuit interrupter protection mandates discussed earlier in this explanation reflect Panel 2's ongoing efforts to enhance electrical safety and protect homes from fire hazards. Abstentions in the voting process can occur for various reasons. A panel member may abstain from voting if they have a conflict of interest, such as a financial stake in the outcome of the vote. Abstentions can also occur if a panel member feels they do not have sufficient information to make an informed decision, or if they are uncertain about the potential consequences of the proposed change. A 2/3 majority is a common requirement for approving changes to codes and standards. This requirement ensures that decisions are supported by a broad consensus of experts and stakeholders. In the context of the NEC, a 2/3 majority vote is needed to approve proposed changes to the code. This requirement helps to prevent changes that are not well researched or that may have unintended consequences. The uncertainty surrounding the inclusion of the proposed arc fault circuit interrupter protection requirements in the code highlights the complex and deliberative process involved in developing and updating electrical safety standards. The NEC is not simply a set of rules, but rather a carefully crafted document that reflects the collective knowledge and experience of experts in the electrical industry. The code-making process involves extensive research, debate, and compromise to ensure that the final product is both effective and practical. The NEC is a living document that is constantly evolving to keep pace with advancements in electrical technology and safety practices. The introduction of combination-type arc fault circuit interrupters marked a significant advancement in arc fault detection technology. Combination-type arc fault circuit interrupters are designed to detect both series arc faults and parallel arc faults, providing comprehensive protection against electrical fires. Prior to the development of combination-type arc fault circuit interrupters, standard arc fault circuit interrupters were primarily designed to detect parallel arc faults. Series arc faults, which can occur in damaged or deteriorated wiring, were more difficult to detect. Combination-type arc fault circuit interrupters incorporate advanced detection algorithms that can identify the unique characteristics of both series and parallel arc faults. This enhanced detection capability provides a higher level of protection against electrical fires, making homes safer for occupants. The 75 amp threshold for parallel fault detection in older arc fault circuit interrupters is an important consideration when evaluating the effectiveness of these devices. This means that a parallel arc fault must generate a current of at least 75 amps before the arc fault circuit interrupter will trip and shut off the power to the circuit. While 75 amps may seem like a high threshold, it is important to note that even smaller arc faults can generate enough heat to ignite nearby flammable materials. This is why combination-type arc fault circuit interrupters, which can detect smaller arc faults, offer a significant improvement in fire protection. In summary, arc fault circuit interrupters are an essential safety device that can prevent electrical fires. The NEC requires arc fault circuit interrupter protection in many areas of the home, and the use of combination-type arc fault circuit interrupters is highly recommended for optimal protection. Understanding the different types of arc faults, the role of the NEC, and the capabilities of arc fault circuit interrupters is crucial for ensuring electrical safety in homes. Electrical safety is a multifaceted topic that encompasses various aspects of electrical systems, including design, installation, maintenance, and usage. It is essential to prioritize electrical safety to prevent accidents, injuries, and property damage. Properly designed electrical systems should incorporate safety features such as grounding, overcurrent protection, and surge protection. Grounding provides a safe path for electricity to flow in the event of a fault, reducing the risk of electric shock. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of electricity when a circuit is overloaded or shorted, preventing overheating and potential fires. Surge protection devices protect sensitive electronic equipment from voltage spikes and surges, which can damage or destroy equipment. Correct installation of electrical systems is crucial for ensuring safety. Electrical work should be performed by qualified and licensed electricians who are familiar with the NEC and local electrical codes. Improperly installed wiring, loose connections, and damaged insulation can create fire hazards and increase the risk of electric shock. Regular maintenance of electrical systems is essential for identifying and addressing potential problems before they become serious. This includes inspecting wiring for damage, testing ground fault circuit interrupters, and replacing worn or damaged components. Neglecting electrical maintenance can lead to a gradual deterioration of the system, increasing the risk of electrical hazards. Safe usage of electrical appliances and equipment is also important. Overloading circuits by plugging too many devices into a single outlet can cause overheating and potential fires. Damaged or frayed cords should be replaced immediately. Water and electricity do not mix, so it is important to keep electrical appliances away from water sources. Education and awareness are key to promoting electrical safety. Homeowners should be educated about the potential hazards of electricity and how to prevent electrical accidents. Children should be taught to respect electricity and to avoid playing with electrical outlets and cords. By prioritizing electrical safety, we can create a safer environment for ourselves, our families, and our communities.